Hello, can we start, sir, with your permission? Hello, good afternoon, sir. Maybe start, sir.
Hello,
Sir, can we start, sir?
I'm not able to hear you properly, ma'am. Can you hear me very well? Hello.
Yes, sir. Your voice is clear.
Ma'am, am I audible, ma'am?
Yes, you are audible now.
Yes, thank
Can
you.
we start?
Sure.
Okay. Good afternoon, all.
Hello, Shraddha madam. Hello. Your voice is very low. Please check.
Hello, am I audible now?
No, it's again very low.
Just a minute, ma'am. Hello,
Hmm.
am I audible now?
Okay, little bit okay. Yes, you can continue.
Okay, ma'am. Yeah.
Be louder.
Yeah. Good afternoon, all. We may now proceed to session 3 for the day. It gives me immense pleasure to introduce today's speaker, Dr. Bhushan Garware. Sir is currently working in data science practice at Persistent Systems Limited, Pune. He is proficient data scientist with more than 6 years of experience in machine learning, pattern recognition, artificial neural network, data analytics, signal and image processing. Sir has his expertise in theory and principles of machine learning teaching, the same at corporates, research institutes and universities, and strong mathematical background of statistics, probability and time series and analysis. Sir has pursued his PhD in Faculty of Technology from University of Pune with Best PhD Thesis, Gold Medal of University of Pune, and Master of Technology from College of Engineering, Pune. He was visiting professor in Vishwakarma Institute of Technology, Pune. Sir has handled many projects related to machine learning. To name a few, customer membership status prediction, anomaly detection in multimedia, viewership data, and deep learning projects like digital pathology image analysis, CCTV based face recognition for remote surveillance. Sir has, to his credit, the India's most prestigious world's largest biometrics project, Aadhaar. Sir was the speaker for various programs like Essentials of Machine Learning, tutorial session at Compute, 9th Annual ACM India Conference, 2 days hands-on workshop on machine learning at Data Intensive Science Workshop, Inter-University Center for Astronomy and Astrophysics. Sir has given hands-on machine learning workshop for graduate students. Sir has also has filed Indian patent in method for standardizing fingerprint images in biometric recognition systems, which was published in 2015, and one Indian and US patent in method and a system for matching fingerprint images obtained from different fingerprint image capturing devices, issued in the year 2016. Sir, we welcome you, sir.
Thank you so much.
May I, may I now request you to please take over the session?
Thank you so much for inviting me for this briefing. Today I'll be talking on introduction to AI. Yeah. I would request participants to be on mute so that there would be less disturbance. If you have any questions, we will take it in the end of this section. So let's get started to introduction to AI. Even if you go in industry or academia, everybody is right now running towards developing inventions, right? So It is very important nowadays to identify the quality of your invention, right? If you are developing something new, what could be an effect of that on the community? So here is a meme where you can see that somebody invented the will and somebody invented the parking ticket. So the impact of inventing will actually change the life, but that doesn't mean that you always look the kind of returns and of money that you get from your invention. So when this question was asked to Bill Gates, because I remember in one of his talk he mentioned that a breakthrough in machine learning can lead to the 10 Microsofts. So when the question was asked to him that according to you, what should be the next bigger invention? He said that the next big invention that would change the way we live should be the ways of generating energy like electricity. You know, a new thing that will come that has to have a power which is close to an electricity. You know what? Electricity was, electric bulb was invented in 1879, but that was an emerging year of an electricity. But this is the situation of 2020. Today, we cannot think our lives without electricity, right? Electricity has become an inherent part of our life. The same thing is going to happen with AI. When this question was asked to distinguished Professor Andrew Ng from Stanford University, he mentioned that AI going to be the next electricity. And why he thinks so? Currently, if you see that there are applications of AI in transportation, applications in construction, surveillance, marketing, smart homes, air conditions, healthcare, online shopping, mobiles, smart grids, solar, industrial, manufacturing, roadways. Everywhere we find applications of AI, right? And that's why a day will come when we start feeling that we cannot live without AI. And that day is not very far. Today, can you take your car on a new city without having your Google Maps on? You don't, right? I don't dare to put my car in a traffic without having navigation on. So today only we have started feeling that AI is inherent part of our life and we cannot live without AI. Now the best thing is that the very good applications of AI are yet to come. And this is the right time to learn this new technology. As you said, this is like a 1879 of electricity. The new things are being invented and 2020 is really far for AI. Today we are finding good applications of AI, but there would be a time where it would be become you know, uh, like a necessity thing for a human being. Now, artificial intelligence is not new thing, and this is very important that whenever you listen any online lecture, series, tutorial, you find that these terms artificial intelligence, machine learning, and deep learning, those things are used interchangeably. Many times people use it loosely. So it's very important to understand what's the difference between artificial intelligence, machine learning, and deep learning, so that you will have a crystal clarity when you go for the next lecture series. You will have a good understanding that in which domain right now we are working on. So artificial intelligence is not a new thing. It was first tossed, this term artificial intelligence was first tossed in 1915, one of the mathematical conferences. And those algorithms were developed, those algorithms were ready on paper. Unfortunately, we were not having good compute power, and the power of those algorithms couldn't be seen at that time. And that's why, even if algorithms were ready, we could not see the actual beauty of those algorithms. And that's why actually machine learning came into the picture. Those were lightweight algorithms with limited amount of data. And this 1980 to almost 2010, this era was dominated by machine learning, the good inventions of random forest, support vector machine, and interesting algorithms. They came into this era. And something very interesting happened in 2010, and thanks to companies who invented GPUs. The moment we had GPUs available for, a common man, you could actually take the algorithms which were developed in this era, and now you start finding an applications here. So 2010 onwards, there is whole boom of deep learning, and in this session also for next 2 weeks, the sessions that you listen, you will find lots of applications of deep learning into this domain. So it is very important first to understand what's the difference between AI, machine learning, and deep learning. You know what? These all three fields are actually a subfield of a very basic field of computer science. The computer science, the goal is to automate the algorithmic process at scale. Very important. Final goal is you don't want to do anything on your own. You want a machine to do your task, right? So while doing an automation, you make sure that your algorithm or your product should scale. That's the overall goal. So the focus is on automation, right? Now, artificial intelligence is a subfield of computer science which says that I'll be doing automation, but while doing that automation, I'll make sure that it will sense, reason, act, and adapt. So, what is an AI? AI is automation which has these four qualities. Your system should be able to sense the environment. Your system should be able to reason. There should be a reason or justification for the action taken by your system or algorithm. It should have an ability to act, obviously, and very importantly, and the last and very important factor is your system should be able to adapt. And that's called an artificial intelligence. But the final goal is I want to automate something. Now, there is a subfield of artificial intelligence which is called as machine learning. And in machine learning, the goal is you will have a training data set and algorithms whose performance improve as they expect to more and more training data over the period of time. Now you understand that people give an example like training a system is like a growing a kid. You expose it to some data and then it learns from an experience, and over the period of time it learns to do the things well. But imagine you don't create explicit training data set for your kid, right? But machine learning is a subgroup of AI where you need an explicit training data. That's a fundamental requirement, right? Based on that, then you start learning an algorithm. There are some exceptions, but basically you have to have kind of a training data, right? And then there is a very interesting understanding on that. The actual definition says that if I expose more data, you should provide, really good performance by algorithms. But one of the limitation of machine learning is, and what people have found is, the accuracy of your algorithms, they increase if you increase the data. But after some time, that plateau is reached. And after a point, no matter how much more data is provided, you will see that their performance doesn't increase. And this is something not people are not liking, because with today's age, we are generating humongous amount of a data. So now if I'm having big data with me, large amount of volumes, and I cannot restrict myself saying that after some time, even if more data is provided, my accuracy will not increase further. So this is one of the limitation of machine learning, and why a new field that came, it's called as a deep learning. So deep learning is again a sub part of machine learning. So don't say that deep learning is fancy and machine learning is not that good. It's not like that. Deep learning is actually a sub part of machine learning where particular task is done by done with the help of a neural network stuff. So it's a hot new thing. So why deep learning is hot? The fundamental difference between machine learning and deep learning is how to handle the data. The basic difference is once you have large volumes of a data available, you will see that there is a significant increase in accuracy from machine learning algorithms to deep learning algorithms. They said that if you have a more data, you can go for a deep learning to get the better performance. And there are still limitations. After some time, you'll still see this plateau, and you never know. In few years, you may have some deep learning thing may come. But right now, we are in an era of deep learning. The biggest significant difference between machine learning and deep learning that we see here is the amount of a data. When it increases, you'll see that deep learning algorithms perform better than machine learning algorithms, right? In other side, some people say that in order to see real beauty of deep learning, you have to have a large amount of a data. If you have a small amount of a data, you may sometimes there is no written published proof of it, but sometimes you'll see that, oh, my deep learning is not performing good, rather my ML algorithm is good. Because once you have a very small amount of a data, you may start overfitting. So your training accuracy would be really high, but your test accuracy will not be good, right? This is one of the limitation of a deep learning. If you don't have sufficient amount of a data, you may end up overfitting, and then obviously your test accuracy will not be good. Okay, so where is artificial intelligence? Okay, so we saw what is machine learning, what is how deep learning is needed, how the progress is met. But where is artificial intelligence? So as I said, the term AI was first tossed by John McCarthy in one of the mathematical conferences. And I really like the vision of this person. You know, this person in 1954 says that an attempt will be made to find kind of a problems which are now reserved for humans. That's so nice. In 1954, Sir John McCarthy said that people will make attempt to solve kind of a problems which currently we feel that reserved for humans. Now, kind of a problem since what? Now you can say that, hey, art, let's take an example of art, right? Art is reserved for humans, right? How can machine do that? But now you see the applications of deep learning, applications of AI, where machine is performing a task which we feel that are reserved for humans. This is amazing. And I'll give you a lot of examples to convince this idea, like the kind of a problems which we were thinking humans can only do, now machines are also doing that. And I like the vision of this person that in 1954 he said that attempts will be made. Okay, so where we saw that AI is actually coming, right? So this was the first event in 1997 when IBM Deep Blue actually defeated Grandmaster Gary Kasparov. Okay, this is an amazing event, and this video is available on YouTube. I would recommend you to have a look at this video. You know what? In 1996, one game was played, and Gary Kasparov, defeated IBM Deep Blue in 1996. And this time he looked a little bit complacent, like how can machine beat me? But in 1997, you actually, it's fun to watch this video, right? So people thought that AI is coming. Now we have machines which are smarter than humans. But I don't want you to sound like these people. You should understand what is going in the back. This is not AI. This is a chess playing machine. This is not the victory of AI, but this is the victory of pure computer science. What was the back inside IBM Deep Blue? So it was a victory of computer science, as I said. It is a victory of great algorithms and fast computing. So what they had is 30 custom CPUs with 20 million moves per minute of processing, and the code was written in C++. So it was, everything was programmed there. The only good thing is that it has a fast processing, right? So this is not the victory of AI. This was simple computer science whose goal is to automate the thing. So it is not an AI, it is a chess playing machine. But still, people thought that AI is coming. But now you should understand that this is computer science. Now there is another event, which is, in 2005, Stanford AI lab wins the self-driving car. Now this is a self-driving car, and this is the road, 132 miles dirty road, and this car actually traveled at 132 miles without driverless car. Now you can relate that driving should be done by human, right? How can machine do that? But as John McCarthy said, attempts would be made to solve kind of a problems which currently we feel that are reserved for humans. Now, if you see this, do you think that there is an AI there, or there is a lot of human handwritten rules in the back? This is also not the victory of AI. What it has, now you have sensors, now you have cameras, radar, lasers, GPS, and many more sensors to understand the road. And then obviously you have a computing, and there are some rules written that if the angle is this and this, then this is how you should drive. So again, this is an victory of computer science. No sense of learning involved so far. So when we saw the learning, the real learning we saw actually in 2011, and this is an amazing event. When IBM Watson supercomputer destroys human in a game of Jeopardy. Most of you must be knowing, but if you are not knowing, then see this. Jeopardy is a game like a KBC that we see in India. The only thing is that there are multiple players, and you can choose the domain, and there is a human host who asks questions in natural language, and this IBM machine responded faster than human beings. And these are the expert Jeopardy players in their domain. Amazing video to watch. I would recommend you to have a look at the Google stuff, right? So here, first time what we saw is machine learning came into the picture. We had a big data sets in memory clusters, 4 terabytes of entire Wikipedia data was used as a training data for this. And then there is a kind of a decision tree, kind of an algorithm to classify the questions and give the answers correctly, right? Again, I'm saying that this is not AI. This is, again, you can say that is kind of an answering machine, but wide domain. You can ask any question and machine will respond to that. But still work is limited, and dedicated architectures and trainings and features and everything were involved into this. Now, where we saw actual AI is coming, right? So this is an event in 2016. Google's DeepMind, beats number one uh, player in an ancient game Go. Now, Go is much more complicated than chess, and Lee Sedol, he was defeated by this machine. Now, what was the difference so far? What we have seen and this particular architecture, when it was asked to the Google teams, this is the victory of a deep learning, and very nicely said that, and this would be the theme of today's talk, and you should understand the difference between it. Now a system has figured out figure out itself how to win the go. That's so nice. Nothing programmed there. System has learned and figure out itself how to win the go. And that's the beauty. Now when you see in your rest of the FDP, there would be neural networks, CNNs, LSTM, deep networks. The beauty is that once the data set is given, they figure out themselves how to win it. So figuring out itself is a key. So what Google Alpha team sees that today it is playing a game of Go. Tomorrow it can start predicting weather. It can start predicting something else, right? So it's just a matter of figuring out something. The moment you create a right data set, system will adapt to it and it will figure out itself how to perform the task. And this, I think, the best part of this, how the progression is about and how are we actually going closer to AI, right? So what else deep learning is doing? So I'll quickly run through it. Generating handwriting. So as I said, you might think that handwriting is unique to me. It's not like I can learn your handwriting, and then once I learn your handwriting, I can have a machine which will write like you. Okay, so problem the things which you think writing is reserved to humans is now done by machine. Twitter bots, typing something, expressing your feelings. You have a bots now, so you see that Trump, this is a bot, whether we really have a people who are stupid. So this is the way Trump tweets. This bot has learned and he has started tweeting like that. So no more, reserved for humans. Deep dream, you felt that painting is reserved to humans. Picasso was a great painter, but now he is not there. So what? I can learn his style of a painting and I can generate new pictures. There was an event in an art gallery, a lady who was expert of looking at a painting. He purchased one painting, and after that deal has done, the owner said that this is not human created. This is actually machine generated painting. So that level of detailing you can generate by using machines. Image colorization, you feed a black and white image and machine will color it. It learn how butterfly looks like, how sky looks like. You have solutions ready for this. Image captioning, if there is an image, now machine can generate a caption to it, and now you can actually create a third eye, or for um, physically challenged people, blind people, you can actually have an application. They will just click a photo and app will talk for them. You can have a real live, real time translator. Okay, so like a person, the translator you have, you don't have to even type it. You hold your phone and you get a real time translator. So all these are an applications of deep learning and the problems which are reserved for us, but machine is solving that. So if machine is also writing articles like to be or not to be, can't machine start coding? Yes, do. There are already applications. where machine can actually, you just express this is what I want to create, and you get a template of a code ready. So the question asked is now, if AI is doing so many things, will there be an issue for me where AI, take my job, right? So the question that comes is, will AI replace me? The short answer is no. Now, stop watching those spy-fi movies that there would be a robot which will come and destroy our cities. No, it's not like that. So when this question was asked to Andrew Ng, that do you think that AI will replace me, or is there any job threat, or is there any threat for my life because of AI? So he said that this is like worrying about population problem on Mars. So we are actually sent one unmanned space shuttle on Mars, and you're worrying about population problem. So we know what are the limitations of this algorithm, what they can do, what they can't do. So just don't worry that AI will replace me. Of course not. So rather than worrying, why don't you think that, it's not a competition, but it's a collaboration. And once you switch yourself into the mode of collaboration, then it wide opens huge opportunities for you to create an application and serve the mankind by using AI. So we will be talking everything on a very positive note, that how machine and human can work in collaboration to serve humanity. Now, for next couple of weeks, you will be having a lot of sessions and everything. I don't know at what stage every individual would be, but my job is, to give this introductory session and bring everybody on the same page, right? So while doing an exciting application, it's very important to have some basics understanding, how machine learning works, how deep learning works, and then probably it would be a right stage for you. You may attend advanced sessions, or you can start with hands-on sessions of that. So with that, I'll just quickly cover basics of machine learning. It is very important to understand when we start journey of machine learning, that how it is different than traditional programming. Okay, so in a traditional programming, whenever a problem is given, whenever inputs are given, there is a person, a programmer, who understands, okay, this is a requirement, this is an ask, and then programmer writes a program, no matter in which language. It could be anything, C, Python, Java, MATLAB, whatever. And then that program is executed by computer, and then computer generates an output. So what you do when you are not happy with the output of this, if you're not happy with an output, you go back and you make changes in your code, right? So if you're not happy with an output, you go back as a programmer and you make changes in your program, right? Now, when somebody asks me what you do into those big companies, we say that in those IT companies, what we do is automation, right? But my question to you is, are we really doing automation? He writes a code, this machine just executes the code and generates an output. Then you still need a human to understand whether this output is correct or not. If it is not correct, you need a person to understand the difference. You want him to come back, make changes in the code, and still keep on doing the things, right? So this still call it as an automation, right? However, in machine learning, the things are different. In machine learning, inputs and output both are given to computer. So what we do is, we say that I will not spend my energy to understand the relations between input and output. I'll not spend my energy to write if and else and kind of a rules on an input. Rather, I'll say to the machine that, look, when this type of an input comes, I want the result like this. And when this type of an input comes, I want result like this. It's machine's job to figure out the relations between them. So the beauty of machine learning is you don't write a code, machine generates a program for you. What you need to give is input and output to machine, and machine generates a program for you. And in machine learning philosophy, this is called as a model. Okay, we don't call it as a program, we call it as a model. And some of you who might have done some kind of a coding in scikit-learn in the past, this philosophy is actually like this. If you see the Python code in scikit-learn, you write a code like model.fit comma y. What does it mean? Model dot fit x comma y. X is your input, y is your output. You actually tell your machine that I'm giving you both input and output. You figure out it and give me a model. Now, this model would be used for the further production, right? So, in the previous slide or in the era of computer science, if writing a program is automation, then machine learning is what? Machine learning is actually automation of automation. Now, you don't even have to write a program. And that's why, you know what? There is a tendency, people start saying, hey, let's do machine learning. Why to spend energy in writing code on our own, right? But for that, the fundamental requirement is you have to have a training data like that. Without data, this won't happen. So there is always a call. People say that, sir, this is I want to solve this particular problem. Can you help me? Please tell me whether this is machine learning problem or not. The very first question I ask is, do you have a training data? If it is not, I'll not be able to solve it. If you come into situation saying that I don't have enough training data, you will have to go into traditional programming approaches where you will code it on your own. So you have to spend an energy. So a typical machine learning situations, nobody writes their own algorithms. So there are many machine learning algorithms which are already there. Your job is to pick right one. Okay, so as I said, there are many machine learning algorithms. They are typically classified into they are basically classified into three buckets. The first one is called as supervised learning, where you get a labels the data ready. So a typical philosophy of supervised learning is you have a right answers ready with you, and you come up with a model, and you have a right answers, and you need to produce more right ones on the test data. Okay, in unsupervised learning, you don't have a label data ready, and I'll come to that, how to do that. And reinforcement learning is an amazing stuff where the environment itself is changing. Okay, so let's get started. What does it mean by supervised learning? So typical supervised learning algorithms are classified into two: regression and classification. When your job is to predict some continuous values, for example, if you want to predict what would be the temperature, so your answer would be 33 or 35 or maybe 9 degrees Celsius. So these are the continuous numbers, right? So when you want to predict continuous numbers, you are into regression domain. So it's very important for you to choose the right algorithm as per your requirement. On another hand, if somebody asks me develop a model which will predict whether today is a hot day or it's a cold day. So I'm not asking about what's the actual granularity here. Like I'm not asking you actual temperature. I'm just classifying, say that tell me whether it's a hot day or it's a cold day. Then it becomes a classification problem, right? In unsupervised learning, in unsupervised learning, there are again, three buckets that we have. One is called clustering. So you group your data together. That's called clustering. And there is another very interesting applications of unsupervised learning is called anomaly detection. And whenever you have something like this, the events which are not very frequent. Okay, so you don't have enough classes, you don't have positive and negative samples, enough samples are not available. I'll explain you with an example. For example, credit card frauds. So if you get the transactional data from banks, you will get thousands of transactional data, which is normal transaction, and very few frauds, right? The frauds don't happen on the regular basis. So in this situation, rather than treating it as a classification problem, you can say that the fraud is an anomaly. It's unusual. It never happens on a regular basis. So there are special classes of algorithm which are designed for this kind of an application. And then obviously a dimensionality reduction, which is again an unsupervised learning stuff. A couple of interesting things. You can use it for feature extraction or feature engineering. Like there are beautiful algorithms like PCA, which you can use as a feature engineering, or you can use it for visualization purpose. So these are the typical class of algorithm that they fall into unsupervised learning. And then there is a third class of machine learning algorithms. It's called as a reinforcement learning. And in a reinforcement learning, your environment is changing, and this is an agent who have to take a next best action based on few things, right? So a very nice example of reinforcement learning is playing a game of a chess. So your next move is dependent on how your opponent is playing, right? You can't have everything hard coded saying that no matter what opponent is playing, I'll play exactly this move, right? So your next move is dependent on your environment. So you defined a reward function. Okay, so you say that what is your reward is, going from one end to another end is my reward, and how can I minimize my damage? So what move I should do so that I can increase my reward and I can decrease my damage? These kind of an application, they fall under the reinforcement learning kind of a situation. So if you see popular machine learning algorithms, so most of you must have heard this name, or somebody might be using also. So typical, you see logistic regression, and you have random forest, k-means clustering, knn classifier, pca, support vector machine, naive bayes, logistic regression, decision tree. So these are the typical algorithms that people learn in their academics, or they use in practice. But even if you master a class, what you would be knowing would be a tip of an iceberg, because there is a lot of literature there in machine learning. So if you see machine learning algorithms, these are the broad range of algorithms which currently available. And in a Bayesian philosophy, you have a naive bayes. In decision tree, you have these kind of a set of algorithm. For dimensionality reduction, not only PCA, you have a lot of other algorithms. For instance base, you have KNN, you have K-means. In regression, you have logistic regression and many other regression rules. So my question is, how much you would learn, right? And every day a new algorithm is being added into this list. So it's very important to understand, whether I should invest my energy to develop altogether new algorithm which will perform like little bit better than all other algorithms that I have on one particular data set, or I should focus on my energy to solve, some kind of a algorithm, some kind of a problems which really need to solve it. So one of the limitation of these machine learning algorithms that you must have seen is machine learning always requires you to bring a data into a structured form. So if you have done some of these algorithms, you will see that a typical machine learning data set looks like this. These are your variables. So x1, x2, x3, up to xn, and you will have a target variable y. So all the problems that you see, you go and Kaggle for data set, you'll see that you people share data set into CSV format, right? So what you're seeing is a structured thing. All machine learning algorithms, they work on the structured data, right? But real life problems are not structured. The real life problems, the real life data that we get, a lot of unstructured data. You get a lot of text, you get a lot of images, you get voice, video, vibration signal, gravitational waves, all the real life signals, they are in unstructured format. And if you want to come up with exciting application, you have to deal with this unstructured data. And this is the second fundamental difference between machine learning and deep learning. Okay, so even if you complete the entire course of machine learning, your situation would be like this. And then you will ask machine that will you help me to extract features as well, because the data is unstructured. And then machine responds like, why not? I need to go deep into it. So the second fundamental difference between machine learning and deep learning is this. In machine learning, you have to have a structured data. So whenever an unstructured data comes, I'm not saying that machine learning cannot handle unstructured data, but you have to have somebody to write a piece of code like a feature extraction, and you will have to convert this into a structured data. The moment you have a structured data, then ML algorithms can help you. But you need somebody to extract the features. As seen, many people still do their PhDs and they spend a lot of energies into this, and lot of efforts, 4 or 5 years are spent on extracting the features from images, extracting features from sounds, extracting features from vibrations, and it will work on their data set after spending 4 or 5 years. Definitely you can come up with quality features and your classification accuracy would be good. But the moment there is some change into this data, because this feature extraction is everything rule based, it breaks. And a very nice example of this is face recognition. It works really good on the data that you have, but moment you put it into product, and if I go there, and you can, I think, relate this with your students also, you know at the time of their B project evaluation, you say that, sir, it works here, please come outside, come within the light, sir, lot of issues. This is because your feature extraction is not natural. So the beauty of deep learning is, in the deep learning, this feature extraction is done by machine itself. So the why deep learning is so much popular is because you can throw raw data into it. You can throw a raw data into it and let machine extract what features it want. You don't have to worry about. It's a machine's job. And then you get your classification out. That's the beauty of deep learning. And that's why you'll see that the success of deep learning is really high, because you don't have to extract the features. It's machine's job to find the features, right? So I hope you got 2 points, two fundamental differences, where to go with machine learning, where to go with the deep learning. When you have humongous amount of a data, go for deep learning. Feature extraction, when you have unstructured data, go for deep learning. Otherwise, if you go in machine learning, you will have to extract the features. Why to do that? Let machine do that. Okay, so that's the fundamental difference between deep learning. Okay, now let's go to the basics of deep learning. So fundamentals of neural network. Okay, if you I will highly recommend. Now this is not a time to teach neural networks, but if you get time before you attend next lectures, I would highly recommend you to get your basics clear around how a typical neural network works, and nice gradient descent algorithm. This is how this gradient descent work. W new, that is new weights, is equal to W old minus alpha times dj by dw. This alpha is called as a learning rate alpha. This j is your cost function, right? Gradient descent, definitely brush up so that you will understand that how weight updates are happening. And once this is done, obviously you will not be having a single neuron. There would be a chain of neurons. What would be an effect of learning rate? And then you must go for this. I hope you remember we learned chain rules in our derivatives, right? So back propagation algorithm, right? So these are the few things I would recommend you to brush up before you go for the next sessions. Then only you will be able to appreciate what is happening in those lecture series. Okay. Obviously, we are not gonna uh, do this manually. There are deep learning frameworks. So I hope you must be seeing some of these names. I'll quickly tell you. Cafe was a framework, which was the first deep learning framework developed by the students at University of Berkeley. And and then there is a Microsoft CNTK, where you actually do not you actually maintain a configuration file, where you maintain that I am having layer 1, layer 2, layer 3, layer 4 kind of thing. And this configuration file, you actually express how your neural networks look like. Rather than going with this configuration file based, people prefer to go with a programmatic way of doing it. And that's why the two things, they came very popular: TensorFlow, Torch, and Theano. Torch was developed in a programming language called Lua. I don't know how many of you learned Lua. I have never coded a single word in Lua, and so as many people. So Torch nobody uses. Now Theano and TensorFlow, they are in Python, but TensorFlow has a Google backup, and Theano give up. So the king is TensorFlow, and Keras is a wrapper on TensorFlow. Now looking at the popularity of TensorFlow, what this Torch guys came is, they come up with a Python version of a Torch, which is called as a PyTorch. And now PyTorch is becoming very popular. So you'll find that there's a fight between TensorFlow and PyTorch. A lot of people still go with TensorFlow. There is a rising trend in the research community, and people slowly moving towards PyTorch. So you can choose which framework that you want. The bottom line that I'm trying to say is, you don't have to do that math manually. Okay, there are frameworks which will do it for you. Huh. So this is very beautiful thing. We call it as a convolutional neural network, and this is what you will be using in lots of applications. And the fundamental difference between a normal neural networks and the CNN is this part. It's called as a convolution module. What you have, this is a typical kernel. A typical kernel looks like this. So if you have done a course on image processing, you'll see that there are different kernels available. A book that I used during my post-graduation was Gonzalez and Woods. And in that Gonzalez and Woods book, you will find that there are so many kernels defined. Sobel kernel, age detection kernel, and blah, blah, hundreds of kernels. Okay. Those kernels are defined by the people after doing so much research, and they say that if this is an image and if you run this kernel over an image, what you get is this particular output. Now the thing is, the beauty in this CNN is, again, I'm not going to cover entire thing. I'll just tell you what's new. The new thing is here, this kernel are not predefined. These kernels are not predefined, and the values of these kernels are also learned. Please try to understand. The values of these kernels are learned. Initially, you have a random values for this kernel. You will pass a data over it. There would be a loss. They say, oh my God, my loss is really huge. You come back, you change the weights, you update the kernel, and then you pass a data again. Till the time you don't get your loss very small, this process happens, and eventually find out, okay, some kernel is set here, which is extracting features from my images. So this part is actually a feature extraction part, and this part is actually a typical machine learning classification task. The beauty here is what features to extract is also learned. This is nothing predefined. And that's why I said, so now I want to relate this with my introductory example that I gave. You know, Lee Sedol, the game of a Go, what they said is, this is using deep learning. Today it is playing Go. Tomorrow it can do something else. The same philosophy comes because nothing is hard coded here. This is all general purpose architecture. Today it can classify cat and dog. Tomorrow it can classify pneumonia or not a pneumonia when X-ray images are given, right? The beauty is this structure figures out how to do it. It figures out how to do it because everything is general purpose, right? So learning the best value of a kernel is a new change that came, right? And that's why the pain of extracting feature is gone. And that's why deep learning is very popular. That's the fundamental difference. I hope I could explain it. Now, the moment you have this kind of a thing in biomedical, you can come up with exciting application. What you need is eventually an image classification task. You need a lot of samples with normal images, a lot of samples with bacterial pneumonia, a lot of samples with viral pneumonia. The moment you have that, machine will figure out how normal X-ray look like, how viral pneumonia look like, and how bacterial pneumonia look. I don't have to extract the features. That's the beauty. There is a nice data set available on Kaggle. We call it as a diabetic retinopathy data set. You have 5 classes, and then you can predict whether it's a class 1 retinopathy or not. Skin diseases, see, these are the different kind of skin diseases. Now imagine with a traditional methodologies, will you be able to extract rules out of it? It's hardly impossible, right? Rather than what you can do is you create a lot of data, throw it in a machine, and let machine look where to look into and call it is a right. So image classification is like a beautiful task, which is like a straightforward noun. Everybody does it, So interesting. It's not that easy, but I'm saying that if two things are there, if the huge amount of data is given and sufficient compute is given, people will produce state-of-art results on that. Another application could be an object detection or segmentation. So people are going a little bit deep, saying that you just don't classify it's normal or not a normal. What you need to give is like object detection kind of situation. So you have to create a data set like this, where you know, you have to create a training data saying that this is an image and this is an area where I'm looking for. There is a lung nodule here, or here is a brain tumor, right? So you actually extract, generate a training data like this, that this is my input image and this is my output image, right? This is my input image and this is my output image. In both sides, I'm having images, and you are actually, it's a typical supervised learning task. You are actually saying, machine saying that, if input image is like this, what output I want is this. And you will get hundreds of, like thousands of samples like this. So these are the human annotated image. Doctor did this. The moment you have that, then you can train a machine, and then you have, machine generated segmentation out. Okay. So the only difference here is, the architecture that you have is called as an encoder decoder architecture, because at that input side you have an image. Here you have a lot of cnn's, and then you again have deconvolution, and here you have an image. So input is an image, output is an image, but you have to create with input output training pairs first. Okay. That's how world is moving, so it look very elegant. The moment the data, training data, is made available, the things are pretty simple. Okay. Now, this is one of an, interesting applications that currently I'm working on, and I'm working with one of the radiology company in the US, where they say that we get lot of data, and we do not have time to see each and every image. Can we come up with a software? So if you see this, this is an image. Based on this image, this is AI enabled diagnostics. So you have that this is 1, 2, 3. This could be the diseases. This is like findings and impression. This data. Now look the complexity. Image is an input and output is a text. So this is a radiology like entities that are extracted, and from that, this is a report. This is an AI generated report on X-ray images. And from that, we are also generating an entity extraction, which can be further used for the, further analytics on the data. So please try to understand, just by making small changes, the module for extracting the features, you will find that the output is, this sky is the limit. You can come up with any kind of an algorithms that you actually want to do, right? And people are actually putting this kind of a systems into production. So sky is the limit. And the good thing is that if you want to work with an healthcare domain, so this kind of an X-ray, so a lot of training data is made available for you. So there is no question. So brats is every day people have, there is a competition called brats, and you will get like GBs of a data for training, right? So similarly for X-ray, there are a lot of chest X-ray, a lot of data is available. And if you want to work with the CT images, there is a data called lung nodule data set, Luna 16. Beautiful. You have an entire slices of CT images and the nodule, it's XYZ parameter as well as a diameter. So everything is provided, you just have to train your algorithms. And then you can think of coming up with something very exciting, like, it will really save the time of a radiologist. You and during this COVID situation, uh, I hope you understand that COVID um, can be seen in CT images much better than X-ray images, right? So a lot of COVID cases were coming, and radiologists were hardly have any time to look into it. So people train algorithms on CT images and the COVID-related features on that, and you just throw to the system, and system will tell whether the person is having COVID or not. Okay, so in this we actually came saying that you upload entire CT image, and then on the screen you will have a nodule 1, nodule 2, nodule 4. You click on the nodule and you'll get all the dimensions of the nodule coming up. So exciting applications can be built, and there is a huge requirement as well, right? So as I said, sky is the limit. And then this is an area, if you go and meet two biologists, those people, they take microscopic images, and they manually count as nuclei cells and everything. So area of interest extraction and epithelium segmentation, tube segment. You will find a lot of research problems. You just meet any biologist in an institute and say what kind of a data that you use. And if you talk to them saying that, tell me your workflow, you'll find a lot of stuff is done manually. And you can say that, hey, you might have done this in the past. Give me some annotations and let me help you to automate this process. Okay. So pathology is an area where you can apply nice applications of AI. Okay. Now, after looking at all these, exciting applications and everything, you must be thinking like, oh no, now I want to do it. How to develop an AI application. Enough talking. Let me know how can I get started. So so if you want to start with machine learning development, okay, so there are few options with you. One is there are libraries available, so or there are cloud platforms or there are web services. Now here I would be a little bit cautious while discussing. See, not everyone would be a researcher. Somebody would be an entrepreneur. Somebody want to make business out of it, right? So based on your interest, your requirement, you should rightly pick the right ones. Do not reinvent the wheel. Don't spend time on the things which people have already done, and don't think of beating somebody. The real challenge now we see that the bigger companies like Amazon or Facebook or Google, the kind of a data that these companies are gathering and the kind of a compute that they have, it's almost impossible for common man like you and me to beat their accuracy levels. So the best thing is that why don't you take their models and develop something on the top of it. So if you want to have an application development, there are three options for you. You have a libraries, you have cloud platforms, and you have web services. So what is web services? Like you can get an IBM Watson, you have Google AI Cloud, you have Azure, or you have a lot of startup companies which are coming. So what do you mean by web service? So what they come is saying that AI as a service. Okay. So what they do is they collect a lot of data and they use a huge team of data science people, and they release their train model for you. So what you need to do is you just need to use their APIs and get your results back. For example, emotion recognition, gender recognition, face expression analysis. You don't have to reinvent these kind of a model. You can use their APIs and you can directly use it. Okay, they are highly accurate. For example, there are some startups which are coming. They say that we are specialized in X-ray imaging. They hire a doctor, a radiologist, and they collect huge amount of data with an association from some medical institute. So they are specialists. Say that we have a model which detects tuberculosis, right? So as a newbie, you cannot go and defeat them, right? So you can still take them and use their services. The biggest disadvantage of using web services is that point number one, you do not have control on their accuracy level because you have not trained it, right? You are just using them as a service. So you do not have any control on the accuracies that these people have faced. So I get a lot of requirements saying that, sir, IBM Watson is not returning me right results because it's not training. People face a lot of issues saying that, sir, face recognition API is not working on Indian conditions, right? Because they are not trained on that kind of a data. Okay, so lack of inclusiveness could be a problem. So you do not have control on accuracy. That's the biggest problem. And second problem is they are paid. So there is no free lunch here, right? So everybody has invested a lot of time and money. So they will charge you. So not a single service is free when you are using a web service. But biggest advantage is you can develop your application within minutes. So if you're using an API service, within no time, you can develop your application. So based how you want to go, you can actually take this call. There is a midway option, and this midway option is actually by using cloud platforms. Okay, so there are cloud platforms like Microsoft Azure ML Studio or Amazon ML or Big ML. Okay, so these cloud platforms, what they do is, uh, what they say is, okay, if you don't want to use the ready-made services, this is an option that we are giving to you. And what is an option? They say that this is a cloud-based platform. You bring your data to us, and on my platform, let's develop AIML applications. Now you will find that they are having absolutely simple and easy user interface. You need to upload your data to these cloud platforms, and there would be few buttons, click, 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 and there would be a button like train, and you will get your trained model ready on that. What they claim is, they claim that saying that we have our own specialist ML algorithms, and you don't have to find the best features, you don't have to choose the right algorithms, you don't have to do training, nothing. You just bring your data and click on a train button, and we will do everything for you, and you will get the best trained algorithm coming back. Got it? So what advantage that you get is, the advantage that you get here is, at least the model that you get, that would be on your custom data. So you won't say that it is not working out for my model. Yes, it will definitely work on your model because it is trained for you on your data. The limitation of this approach is privacy concerns. In order to get that data trained on these platforms, what happens is you have to upload your entire data on their platform. The moment you upload your data on their platform, you lose the privacy, right? And you know what? In many applications, in many regulated industries, we find that our customers are not ready, especially the customers in the domain of banking and finance, and the customer in the domain of healthcare, because healthcare data is so precious. They don't say that, I'll not allow you to send my data on any of the cloud platforms. When I run any fraud detection kind of an algorithm, my customer says that, hey Bhushan, remove the LAN cable and now run your algorithms here. I want to see how it goes. My data should not go outside. In that case, these approaches will not help you. Okay. The another limitation for this is, because these are managed application, you don't have a fine grained control. Now Amazon is claiming that we have autopilot and we will find the best proprietary algorithm for you. But the thing is, I do not have control. I'm not tuning the parameter the way I want, right? I want to, if you want that complete flexibility, you won't get it on this platform. Plus, these all platforms are chargeable. Okay, so this is midway. The advantage is, at least you will get better accuracy level because it is trained on your data. And then there is an option of using libraries. Okay, so libraries like the open source libraries or paid libraries that you have, where you have an entire control on an entire life cycle of this. So if you are a learner, I would recommend you to start with libraries, and then you can use cloud platforms and then web service based on an application. But it's in web services, you don't have to even learn AIML also. Here, at least you need to learn a little bit, but rest of all, it's simple button clicks. But libraries, they are free, but there are efforts to train right, in a proper way. But the biggest advantage is you have a full control on entire pipeline. So you can choose your own feature engineering stuff. You can choose your algorithm. You can fine tune it, evaluate the way you want. And that's why library is the best option to go for. So if you go for the libraries, these are the typical steps that you will have to perform on your own. Like you have to generate a label data first, then you have to train and split your data. Then learning algorithm, this is an iterative phase. You have to play with different algorithms. Out of that, you have to choose, okay, this is the right algorithm with the right parameters. Then you go for final model. Then here you have a cross validation and evaluation of that. and then you have to create a prediction model. So the job doesn't end here after training. If you want to productionize it, again you have to take that trained model and you have to deploy it somewhere, either on cloud or on prem somewhere. But all those efforts you will have to do it. Compared to cloud-based platforms, once the model is trained, there will be a one button called deploy, and then you get a URL which you can hit from any client and you get an inference. So everything is managed, but you have to pay. But in here, you're not paying anything, but you have to do everything on your own. So trade-off is there, and you need to handle it based on comfort level that you have. Okay. So growth drivers in AI in healthcare. So these are the typical points where AI is why AI is very popular nowadays. Is one is increasing individual healthcare expenses. So if you go in the US, if you want to go for an eye test, you have to book an appointment. So if there is some problem with your eye, you cannot go and immediately see a doctor. You have to book an appointment and you don't get it immediately. So problem happening with your eye is today, right? But you will get an appointment after 2 weeks. This is not fair, right? So it's the system is very expensive. So then AI can help you. If not a doctor, you can have an at least preliminary check done by using machine, which can give you some kind of a prescription just to pull on a time, right? So these are some interesting application that you will see. Imbalance between health workforce and patients. Um Doctor versus patient ratio is really, really low, especially in India. And we have seen the situation in COVID time that we hardly had any expert and so many patients, where AI can definitely uh, continuous shortage of technicians and staff, all these stuffs, where which are actually saying that how AI can help in the healthcare domain. If you're working in the country like India, there could be some potential challenges also. Like in India, the data that we get may not be in a structured format. It may not be in a digital format also. So a lot of coordination is required. So you'll see that there are, collaboration is a one point, which is very important. I've seen that there is a lot of interaction with software companies and medical institutions. And I believe that soon there would be a lot of interaction with academia and medical institutes. So if you are in academia, why don't you reach to any medical college and meet a professor there, professor of radiology or professor of something, and you can ask him what are your workflows and how you create a data. So if there is a good collaboration that's saying that medical institute will give you a data and academician will give you models, this would really click well. And in India, the rules are not that strict as US, like FDA clearance and something. So you can still have an a kind of a recommendation system for a doctor. I'm not saying completely outsourcing the job of a doctor, but you can definitely save doctors time, right? So this is how a lot of synergy that I'm seeing in this domain. And India is a potential market where you have a huge population and scarcity of doctors. So AI is definitely going to be needed, and it's going to be the future in India. Now, there is another school of thought, and I believe it's very important to tell you at the beginning only. I'll have a 10-15 minutes for Q&A in the last, but this is very important point is, you know, you will for next 2 weeks and after that, or even if you enter into your PhD, um, you will realize that, 99% of the time efforts are put to develop accurate algorithms, and even I do the same thing, but the problem is whenever I interact with my customers, uh, I say that, see, I got a publicly available data and I have trained my model and it's 95% accurate on paper. But the first question that comes from our customers saying that, why should we trust you? Why should we trust your AI system? I say, see, it is accurate. but there is no guarantee that it will work on their situations, right? And what is a guarantee that AI has really learned the right features? When I started the session, I told you the beauty of deep learning is features are learned on their own, but this is completely mathematical process, you know. So there are many evidences where the accuracy on paper looks really good, but the intended features are not learned. The Your algorithm found some bias in the data. Accuracy may look good, but it is not actually that good. It is not actually the right features are not learned, right? So a new school of thought which is coming, and you should be aware right in the beginning that bring the best accuracy models, but this is not the end game. So accuracy of AI models undoubtedly the most important factor. However, only accuracy is not enough. My model is accurate, the game is not finished. Actually, the game starts after having an accurate model, because now my highly accurate model is ready. Is your model ready for other challenges? Okay, so that all comes into the domain of responsible AI, where now you have an accurate AI model ready with me, and the question is about the responsible usage of it. And there are many aspects of that as well. So, first is about interpretable and explainable AI. So, it's very important to understand you have a trained model, but can you justify the decision of your model? It is called as an explainable AI. So only binary decision, yes or no, is not enough. You need to tell me why. Why do you think so? The person is having cancer. Why do you think so? The person is having COVID. It's a model's responsibility to explain the decision. Okay, so after accuracy, you have to think about aspects like interpretable and explainable AI. Then secure and private AI. Whether your model is secure or not, are you preserving the privacy of a people? Are you preserving the privacy of the data that you gathered from a patient while using it? Is your AI model secure? Can somebody attack your AI model and the decisions of your model can be changed easily? So, how secure your model is? Then, whatever AI algorithm or whatever AI model that you have developed, is it ethical or not? So, is there any sociological unfairness involved in your model? So, you must have seen the examples of algorithms like word to vec, very popular word to vec word embedding algorithm. So, they say that it can solve analogies really well, and like they form an analogy very well. But one of the biggest limitation that they saw is like you'll see that man as to professor and woman as to assistant professor, which is unfair, right? So this is sociologically unfair. We have seen that many face recognition algorithm do not recognize people, black people, which is bad because they are not trained in their training data doesn't include that. So these all are the sociological unfairness that are seen in an algorithm. So if you're going for a product development, you also need to see the ethical effect of that. The next topic is a reproducible AI. Because AI, developing deep learning models is an iterative process. During the process, you create hundreds of versions of a model with different algorithm, different parameters, different versions of the data. You should be able to reproduce each and every. And this is one of the requirement when you go for FDA clearance. Okay. Uh, they test your models and say that now bring it to the next version on the same data, whether your answers of your model are exactly correct or not, whether your work is reproducible or not. Reproducible AI is another aspect where how you are actually putting expert in loop, because your end users of your AI products are not domain experts. If you develop some algorithm, data scientist is not going to use it, a common man going to use it. So how you handle, it's a very nice thing in accessible UI that you must have experienced that, like if somebody is showing you a demo, And if demo doesn't work, normally we laugh and say that, hey, your program is not doing good or there is a bug in your program. But you try to understand that AI is not designed to give 100% right answers. Yes or no? So how can you handle failure in your system? You can relate it with interaction with Alexa. So if you talk to Alexa and sometimes Alexa won't understand what you are saying, look how nicely it handles it. So this is called as a design to handle failure. So these all are very important aspects beyond accuracy. So if you want to actually get out of the textbooks and go to the real market, and when you try to sell your AI product, apart from accuracy, these are all other factors you have to take into consideration, and every factor has an open-ended research problems that you'll find in all those areas. So with that, I think I will take a pause here, and I'm happy to take any questions. I would love to answer if I can. So over to you, ma'am.
Thank you.
If there are any questions, let me know.
Yes, sir. There are a few questions from the participants. The very first question is, as no